Hello, and welcome to this video on synthetic data. In this video, we'll explore what synthetic data is, why it's important and relevant for data science and machine learning applications, and how it's used in different industries and domains. Synthetic data is artificially generated rather than collected from real-world scenarios and sources. Synthetic data can be used to augment, replace, or complement real data depending on the needs and goals of the users. Synthetic data can also be used to create new data that doesn't exist in reality, such as data from hypothetical scenarios or future events. Synthetic data has many benefits and challenges for data science and machine learning applications. Some of the benefits are synthetic data can help overcome the limitations and challenges of real data, such as scarcity, imbalance, bias, noise, privacy, and ethical issues. Synthetic data can help improve the quality and performance of data analysis and machine learning models by providing more data, more diversity, more variability, and more control over the data generation process. Synthetic data can help enable new and innovative data applications by allowing users to create and experiment with data that is otherwise difficult, expensive, or impossible to obtain or generate. Some of the challenges are synthetic data can be difficult and complex to generate, especially when it needs to mimic the characteristics and patterns of real data, such as the distribution, correlation, causation, and semantics of the data. Synthetic data can be unreliable and inaccurate, especially when it's not validated or verified against real data, or when it's not representative or relevant for the intended use case or scenario. Synthetic data can be misused and abused, especially when it's used for malicious or unethical purposes, such as deception, manipulation, or fraud. Synthetic data is used in various industries and domains, such as healthcare, finance, education, entertainment, and more. Some of the examples of how synthetic data are used are in healthcare. Synthetic data can be used to create synthetic patient records, medical images, and clinical trials to protect the privacy and confidentiality of real patients and to enhance the research and development of new treatments and diagnostics. In finance, synthetic data can be used to create synthetic transactions, credit scores, and market data to reduce the risk and cost of data breaches and compliance violations, and to improve the testing and optimization of new products and services. In education, synthetic data can be used to create synthetic students, teachers, and courses to increase the availability and accessibility of educational data, and to support the personalization and evaluation of learning outcomes and interventions. In entertainment, synthetic data can be used to create synthetic faces, voices, and scenes to enhance the realism and diversity of media content and to enable the generation and manipulation of novel and creative content. These are just some of the examples of how synthetic data is used in different industries and domains. There are many more applications and possibilities that synthetic data can offer for data science and machine learning. Diving deeper into the different types, techniques, and tools of synthetic data generation, we'll explore the difference between fully synthetic data and partially synthetic data and give some examples of each type. We'll also mention some of the criteria that can be used to classify synthetic data, such as the level of realism, the degree of privacy, and the purpose of generation. Then we'll explain the main methods and algorithms that are used to create synthetic data, such as statistical distribution, agent-based modeling, and deep learning. We'll also mention some of the advantages and disadvantages of each technique and how they can be applied to different use cases and scenarios. Finally, We'll introduce some of the popular and emerging tools and platforms that can help users generate synthetic data, such as Synthetic Data Vault, GANs, VAEs, and others. We'll also mention some of the features and functionalities of each tool and how they can be integrated with other data systems and workflows. Let's start with types of synthetic data. Synthetic data can be broadly divided into two categories: fully synthetic data and partially synthetic data. Fully synthetic data is data that is completely generated from scratch without using any real data as input or reference. Fully synthetic data can be used to create new data that does not exist in reality, such as data from hypothetical scenarios or future events. For example, fully synthetic data can be used to create data for a new product or service that is not yet launched, or data for a new market or customer segment that hasn't been explored yet. Fully synthetic data can also be used to create data that is difficult, expensive, or impossible to obtain or generate from real sources, such as data from rare or extreme situations or data from sensitive or confidential domains. Partially synthetic data is data that is partially generated from real data by modifying, augmenting, or replacing some or all of the real data. Partially synthetic data can be used to augment, replace, or complement real data, depending on the needs and goals of the users. For example, partially synthetic data can be used to increase the quantity, diversity, or variability of real data by adding more data points, more features, or more noise to the real data. Partially synthetic data can also be used to protect the privacy and confidentiality of real data by removing, masking, or anonymizing some or all of the identifying or sensitive information from the real data. Synthetic data can be classified according to other criteria, such as the level of realism, the degree of privacy, and the purpose or generation. The level of realism refers to how closely the synthetic data resembles the real data in terms of the distribution, correlation, causation, and semantics of the data. The level of realism can range from low to high, depending on the quality and accuracy of the synthetic data. Low realism synthetic data is data that's easily distinguishable from real data, either by humans or by machine inspection. Low realism synthetic data quality can be useful for testing and debugging purposes or for creating stylized or artistic content. High realism synthetic data is data that is indistinguishable from real data, either by human or machine inspection. High realism synthetic data can be useful for training and evaluation purposes or for creating realistic or immersive content. The degree of privacy refers to how well the synthetic data preserves the privacy and confidentiality of the real data in terms of the risk of re-identification, inference, or disclosure of the real data. The degree of privacy can range from low to high, depending on the security and protection of the synthetic data. Low privacy synthetic data is data that is vulnerable to privacy attacks, either by malicious or unintentional actors. Low privacy synthetic data can pose high ethical and legal issues, especially when the real data contains personal or sensitive information. High privacy synthetic data is data that is resistant to privacy attacks, either by malicious or unintentional actors. High privacy synthetic data can provide ethical and legal benefits, especially when the real data contains personal or sensitive information. The purpose of generation refers to the intended use case or scenario for the synthetic data, in terms of the goal and objective of the data analysis or machine learning application. The purpose of generation can vary from exploratory to explanatory, depending on the nature and complexity of the data application. Exploratory synthetic data is data that is used to discover and understand the data, such as finding patterns, trends, or outliers in the data. Exploratory synthetic data can be useful for data visualization, data mining, or data summarization applications. Exploratory synthetic data is data that is used to explain and predict the data, such as finding causes, effects, or relationships in the data. Explanatory synthetic data can be useful for data modeling, data inference, or data optimization applications. These are some of the ways to classify synthetic data according to different criteria. There are many more ways to categorize synthetic data depending on the context and perspective of the users. Now, let's move on to the techniques of synthetic data generation. Synthetic data generation is the process of creating synthetic data using various methods and algorithms. Synthetic data generation can be performed at different levels of abstraction, such as data level, the feature level, or the instance level. Synthetic data generation can also be performed using different approaches, such as the top-down approach, the bottom-up approach, or the hybrid approach. The data level synthetic data generation is the process of creating synthetic data at the data level by generating the entire data set from scratch without using any real data as input or reference. The data level synthetic data generation can be performed using the top-down approach, which is the approach of generating the data from high-level specification or model, such as statistical distribution, a mathematical function, or a logical rule. For example, the data level synthetic data generation can be performed using the statistical distribution method, which is the method of generating the data from a predefined or estimated probability distribution, such as normal distribution, binomial distribution, or Poisson distribution. The data level synthetic data generation can also be performed using the agent-based modeling method, which is the method of generating the data from a simulation of a complex system of multiple interacting agents, such as a social network, a traffic system, or a biological system. The feature-level synthetic data generation is the process of creating synthetic data at the feature level by generating new or modified features for the existing data, using some or all of the real data as input or reference. The feature-level data generation can be performed using the bottom-up approach, which is the approach of generating the data from a low-tier observation or measurement, such as sensor reading, a pixel value, or a word token. For example, the feature-level synthetic data generation can be performed using the deep learning method, which is the method of generating the data from a neural network, such as the convolutional neural network, a recurrent neural network, or a generative adversarial network. The feature-level synthetic data generation can also be performed using the variational autoencoder method, which is the method of generating the data from a probabilistic encoder-decoder model that learns a latent representation of the data and samples new data from the latent space. The instance-level synthetic data generation is the process of creating synthetic data at the instance level by generating new or modified instances for the existing data, using some or all of the real data as input or reference. The instance-level synthetic data generation can be performed using the hybrid approach, which is the approach of generating the data from a combination of different methods and algorithms, such as the statistical distribution method, the agent-based modeling method, the deep learning method, or the variational encoder method. For example, the instance-level synthetic data generation can be performed using the synthetic data vault method, which is the method of generating the data from a database of real data by applying various transformations and operations to the real data, such as sampling, perturbation, aggregation, or synthesis. These are some of the main techniques of the synthetic data generation, according to different levels or abstraction and approaches. There are many more techniques of synthetic data generation depending on the type and complexity of the data. Finally, let's talk about the tools of synthetic data generation. Synthetic data generation tools are software applications or platforms that can help users generate synthetic data using various techniques and methods. Synthetic data generation tools can provide different features and functionalities, such as ease of use, the flexibility, the scalability, and the interoperability of the tools. Synthetic data generation tools can also be integrated with other data systems and workflows, such as the data collection, data storage, data processing, data analysis, and data visualization systems and workflows. Some of the popular and emerging tools of synthetic data generation are Synthetic Data Vault. Synthetic Data Vault is a synthetic data generation tool that can generate synthetic data from a database of real data using the Synthetic Data Vault method. Synthetic Data Vault can generate synthetic data for various data types, such as numerical, categorical, temporal, spatial, or relational data. Synthetic Data Vault can also generate synthetic data for various data domains, such as healthcare, finance, education, or entertainment. Synthetic Data Vault can provide high privacy and high realism synthetic data by preserving the statistical and semantic properties of the real data while protecting the identity and confidentiality of the real data. Synthetic Data Vault can be accessed through a web interface, a command line interface, or an application programming interface. GANs. GANs are synthetic data generation tools that can generate synthetic data from a neural network using the deep learning method. GANs can generate synthetic data for various data types, such as images, videos, audio, or text. GANs can also generate synthetic data for various data domains, such as faces, voices, scenes, or stories. GANs can provide high realism synthetic data by learning the distribution and features of the real data and generating new data that is similar but not identical to the real data. GANs can be accessed through various frameworks and libraries, such as TensorFlow, PyTorch, or Keras. VAEs. VAEs are synthetic data generation tools that can generate synthetic data from a probabilistic encoder-decoder model using the variational encoder method. VAEs can generate synthetic data for various data types, such as images, videos, audio, or text. VAEs can also generate synthetic data for various data domains, such as faces, voices, scenes, or stories. VAEs can provide high diversity synthetic data by learning a latent representation of the real data and sampling new data from the latent space. VAEs can be accessed through various frameworks and libraries, such as TensorFlow, PyTorch, or Keras. These are some of the popular and emerging tools of synthetic data generation according to different techniques and methods. There are many more tools of synthetic data generation depending on the type and complexity of the data. To summarize the main points and takeaways from this video and provide some recommendations and best practices for synthetic data responsibility, let's start with the summary of the video. Here are some of the key points that we covered. Synthetic data is data that is artificially generated rather than collected from real-world sources. Synthetic data can be used to augment, replace, or complement real data, depending on the needs and goals of the users. Synthetic data can also be used to create new data that does not exist in reality, such as data from hypothetical scenarios or future events. Synthetic data has many benefits and challenges for data science and machine learning applications, such as overcoming the limitations and challenges of real data, improving the quality and performance of data analysis and machine learning models, enabling new and innovative data applications, as well as being difficult and complex to generate, being unreliable and accurate, and being misused and abused. Synthetic data is used in various industries and domains, such as healthcare, finance, education, entertainment, and more. Synthetic data can be broadly divided into two categories: fully synthetic data and partially synthetic data. Synthetic data can also be classified according to other criteria, such as the level of realism, the degree of privacy, and the purpose of generation. Synthetic data is the process of creating synthetic data using various methods and algorithms. Synthetic data generation can be performed at different levels of abstraction, such as the data level, the feature level, or the instance level. Synthetic data generation can also be performed using different approaches, such as the top-down approach, the bottom-up approach, or the hybrid approach. Some of the main techniques of synthetic data generation are statistical distribution, agent-based modeling, deep learning, and variational autoencoder. Some of the popular and emerging tools of synthetic data generation are synthetic data vault, GANs, and VAEs. These are some of the main points and takeaways from the video. We hope that you learned something new and interesting about synthetic data. Now, let's move on to the recommendations and best practices for using synthetic data effectively and responsibly. Here are some of the tips and suggestions that we have for you. Before using synthetic data, you should always define your data needs and goals, such as the type, quantity, quality, and purpose of the data that you want to generate or use. When generating synthetic data, you should always validate and verify your synthetic data against real data, such as by comparing the statistical and semantic properties, testing the data analysis and machine learning models, and checking the data quality and accuracy. When using synthetic data, you should always respect and protect the privacy and confidentiality of the real data, such as by following the ethical and legal guidelines, applying the appropriate privacy-preserving techniques, and minimizing the risk of re-identification, inference, or disclosure of the real data. When sharing synthetic data, you should always disclose and document the source and method of the synthetic data, such as by providing the metadata, the provenance, the assumptions, and the limitations of the synthetic data. These are some of the recommendations and best practices for using synthetic data effectively and responsibly. We hope you'll follow them and use synthetic data wisely and safely. Finally, let's talk about the current and future trends and challenges of synthetic data. Here are some of the topics and issues that we think are important and relevant for synthetic data. The increasing demand and availability of synthetic data, as more and more users and applications require and generate synthetic data for various data types, domains, and purposes. The improving quality and performance of synthetic data, as more and more techniques and tools are developed and improved for generating more realistic, diverse, and reliable synthetic data. The evolving ethical and legal implications of synthetic data, as more and more questions and concerns are raised and addressed regarding the privacy, security, and accountability of synthetic data. The emerging opportunities and risks of synthetic data, as more and more possibilities and challenges are created and faced by using synthetic data for new and innovative data applications. These are some of the current and future trends and challenges of synthetic data. We hope you'll keep an eye on them and stay focused and informed about synthetic data. This is the end of the video on synthetic data. We hope you enjoyed watching and learning from this video. If you did, please give this video a like, share it with your friends and colleagues, and subscribe to our channel for more videos on data science and machine learning. If you have any feedback or questions, please leave them in the comments section below. We'd love to hear from you and answer your queries, and thank you for watching and seeing you in the next video. Bye.